So this is a question on for junior college H2 maths. It is a topic. It's on the topic of recurrence relation and sequences. So a sequence of so let's take some time to understand this question. So this is a sequence of positive real numbers. Positive numbers are numbers with a plus sign in front, right? Negative numbers are numbers with negative sign in front. And real numbers are numbers like 1.342, 1, 2, 3, 5, 5.6. All these are real numbers. Even negative numbers are real numbers, but here we only want the positive real numbers. So x1, x2, and x3 are actually positive real numbers, except we don't know what they are, right? And what the clue given by the question is that these numbers, this sequence of numbers, satisfies the recurrence relation. That means repeatedly the relation between the number before and number after, right? Number before and number after are related by a formula, this one. So let's say, for example, where n are integers, n is an element of positive integer. This symbol simply means that n are positive integers like 1, 2, 3, 4, 5. So let's say when n equals to 1, for example, when n equals to 1, this is x2, right? This is x2. What is this? This is x1, because n we substitute into 1. n equals 1 we substitute into n. So when we substitute 1 into n, so this 1 plus 1 is 2. So x2 equals to square root 3x1 plus 1. This is what it means. So let's say, for example, my x1, when n equals to 0, this is x0, but when n equals to 1, okay, let's say when n equals to 1, and let's say if I tell you that my x1 is 1, then what is your x2? If my x1 is 1, this is 3 times 1 plus 1 is 4. 4 square root 4 is 2. So when x1 is 1, my x2 is 2, right? Because 3 times 1 plus 1 is 4, 4 square root is 2. So that's when my n is 1, this is x1 and this is x2. That's why this is then, let's say my x2 is 2. If my x2 is 2, this one will be 6 plus 1, 7, square root 7. So my x3 is 7, square root 7. My x3 is square root 7. So on and so forth. And this is a sequence. So let's explain using, let me use this calculator to show you what I mean, right? So let's go to the main page. Let's switch this to the sequence mode first. Okay, it's already in sequence mode. This SEQs means sequence mode. Okay, when it's in sequence mode, we can use this to do a sequence. So my n minimum, I have set it to, I bring the cursor up, I have set it to 1. That means my index n equals to 1. When this the minimum value of my index is 1. So I start from x1. And un minimum means x1. That means this calculator does not have x, right? You just use u to represent any unknown. So in this case, ours is also unknown. Doesn't matter whether it's x or it is u. It doesn't matter in the calculator. Anyway, as long as the formula is correct, it will describe the same sequence. Doesn't matter what is this, right? So in this case, we treat our u as x, right? And then okay, our minimum index is 1. So we start from x1. And let's say our minimum that means if my n minimum is 1, this n minimum is 1. So my u1 equals to, what do I want it to be? I let it be 1. Just for example, say I choose it to be 1. There's nothing here that says it's 1, but I choose it to be 1 for now. So then this is un is the meaning our xn. But then in this case, you see our left side is xn plus 1, and this is xn. So I can't change this side because calculator by default they let it be un. But that means if my n plus 1 becomes my n must become my n minus 1. Then it will mean that okay, this is the current term and this is the previous term. It means the same thing, even though this is n plus 1. This means that this is current term and this is the previous term, because the index n will be always 1 less than the index here. The index here will always be 1 less than the index here. So let's say how I use this formula on the calculator. You see, right, this n, minus 1. So I press the square root. Okay, so maybe I start from scratch. I clear this, I go up, I clear this. Okay, I let the minimum index be 1, so n minimum equals to 1. So un, I change this one n plus 1 by put this as un. No, I didn't put this as un, but the calculator actually default it to un. So I have to make the adjustment here. This n, I must make it into n minus 1. So first thing what I do is I will do a square root. Right, it is this square root, alright. And then I press 3, and then I do this. And then to get x, how do I get? I actually, in this case, it is u, so I press the blue button and I go to this 7. 7 on top, there's actually a small u here, you do see it. Yeah, so you want to get v, you press second 8. You get w, you get u, second 9. But in this case, we want u because this is this u, exactly. So then I want to change this to n minus 1 because, as I mentioned, I put n minus 1. This is the index. This is actually u small n minus 1. Right, this is how it is represented in the calculator. So, and then I need to add a 1. Okay, and all this is inside the square root. Just go back and check. Yep, actually I don't need this bracket. Yep, this means 3 times un minus 1 plus 1. Okay, and the un minimum, okay, I select it, I choose it to be 1. Doesn't have to be 1, can be other numbers. But I just want to show that if my beginning number is 1, what is the sequence of number that I'm generating? As mentioned, if my u1 x1 is 1, so 3 times 1 plus 1 it should give 4. Then this one, my x2 should be 2. Let's see if that's the case. That's the second table. You see, my first number is 1, the second number is 2. If I substitute 2 again, I get square root 7. Square root 7 is 2.6458. So and so forth, we get a sequence of number. This is what I mean by sequence number that is described by this formula. And now, we can, besides, just now I used the second and then press table. That's why a table is generated out of the formula that we key in. Now, if I want to graph it, right, this actually means the same thing as the table, except that now this is that, for example, this is when n equals to 1. So this is the value of my x1, which is 1. When my n equals to 2, this is the value of my x2, which is 2. And so on and so forth. You see that the value of the n, the xy actually converges. As it goes, the n becomes larger and larger. It converges to a certain number. And what is the number? Let's go back to the table and see. Do you see that it starts to converge to a certain number? At first, the number is very different, but towards later, when the n becomes very large, when the n here becomes very large, it becomes the same number. It doesn't change anymore. The change is so small that it cannot be reflected in the calculator. It's just some small changes at the very back. So what does it mean? Okay, what does it mean for a sequence to converge? It means that a string of the number, right, progressively converge, come to us together to a certain number and does not changes thereafter. So it changes so small that you can't see. Right, just imagine if a pail of water decreased by half every day. Alright, eventually it's going to, the volume of the water is going to be so small and it converge to 0 as if there's no water in the pail, right? So 0 is the volume of water converge to that 0. The same thing, a sequence of number can converge a single number, right? And that's the case. The number that it converge to, in this case, 3.23028. But does the sequence always have to converge? Not necessary. It can diverge. That means it can go to infinity. It can never come to a single number. It may go to 2 number. It may converge to 2 number, but that's not convergence. That's called divergence in maths. So converge, it has to converge to a single number in order to say that, okay, converges. So now the sequence, given the sequence converges to L, that means, let's say the question tell you that since this sequence of numbers converges to a single number, and they want us to find what is that number, right? Okay, given that we know that, okay, let's see the graph. Okay, let's see the graph. Okay, to get the graph, you don't press the blue button, you just straight away press graph. But if you want the table, you press the blue button and then press the table. That's it. So when you see the graph, you see that as n becomes very large, these two value is almost the same, isn't it? So to find that value, we can assume that we can let the number that the sequence converge to be L. And when n is a large number, xn and xn plus 1. It means when n is very large, imagine this is a very large number, then xn and xn plus 1 almost the same number. We want to find that number, what do? We let L be that number. And L would be equals to xn plus 1 and xn. That means the number after and the number before. It will be equal when n is a large number. So that will mean that the L that we find, right, if we substitute, let L equals to this, and we substitute into the equation, this L that we find will be exactly the number that the sequence converges to. Let's prove this. Let's show that it is the case. So now L, I substitute into this equation. I replace xn plus 1 by L. I also replace the xn by L. And see, you see the xn plus 1 is replaced by L, xn is replaced by L. And then what do? I square both sides. This is making the subject of the formula, make L the subject of the formula, something that we learned in secondary 2. So we square both sides. This side becomes L square, and this side becomes 3L plus 1. Correct? And now, if L square equals to 3L plus 1, and we shift the 3L plus 1 to the side of L square, and then we see that you'll get L square minus 3L minus 1, we get equals to 0. Right, this is a quadratic equation, and you can solve it using this formula. Right, minus b plus minus square b square minus 4ac over 2a, where b is the coefficient of L, meaning minus 3. A is the coefficient of L square, which is 1. 1 L square is just L square, right? And minus 1 is the constant. It's the constant c. Right. So A, B, and C. So minus B is my minus 3, so I substitute inside. B square is my minus 3 square, and my A is 1, so I substitute inside. C is my minus 1, so I substitute inside. And so 2 times A, which is 2 times 1. So this one, I will get 2 values. Because let's say if I key into the calculator, the plus, with the plus sign, I ignore the negative sign for my first answer, I use the plus sign. And then we calculate this value. We'll get 3.3028. If we use the minus sign, ignore the plus sign, we'll get the second value. So L has 2 values. L can take this value or that value. So now we say L, the exact value of L, we say that the sequence converges to what? This could be the 2 values of L that the sequence converges to. Then the next part of the question is use the calculator to determine the behavior of the sequence when x1 equals to 1. Means actually the first term actually matters. The first term that we start with actually matters. Let me give you an example. Right. For example, let's say if we go back to the formula here, the first term that we choose is actually this term. We choose it to be 1. And you see the table take this value. And it eventually converges to 3.028. It start with 1, and then the second number is 2.6458. But let's say if I go back and change this number 1, I go and change to 10. My first number will be 10. It will no longer be 1. And my second number would not be 2. It will be 5 or 5, 6, 7, 8. So depending on where my first number starts, the subsequent string of numbers will be different. And let's say if I go down further, and you see that, okay, it converges, but it's decreasing. The values are decreasing. And it converges to a certain value. Surprisingly, it's the same value as we see as just now that sequence. So no matter what, this is what is the first term in this sequence. It happens that for this recurrence relationship, for this sequence, right, no matter you start from a small number or big number, it happens to converge to this number. But it's not always the case. So let's see, what if, for example, if I choose this number to -1, does it give me the same number? No. Now you see all the number error. What does it mean? It means the sequence actually diverges. It diverges, that means it does not converge to a number. Instead, it becomes an error number, diverges after the first number. Because after you put -1 inside, what happened? This one becomes -3. -3 plus 1 is -2. Square root of negative number, you get an error. That's why it doesn't mean that for all numbers it will converge. The first term that we choose matters. That's why the question asks, tell you to determine the behavior of sequence when x1 equals to 1. And okay, so we go back and say, okay, my x1 is equals to 1. And we see the table. And we see the graph. The sequence converges. You can say that the sequence converges to 3.3028. How do I know? Because I see the table and I know. Furthermore, this thing that I find, this thing that I solve also tell me that the sequence converges to 3.3028. So I'm very sure that the sequence converges to 3.3028 when x1 equals to 1. Actually, in fact, the sequence is a increasing or decreasing sequence. When my x1 is 1, it's an increasing sequence. The numbers are increasing. Correct. So we can say that it is an increasing sequence that converges to 3.3028 when x1 equals to 1. Now, the third part of the question is this. They want you to prove graphically that xn, the current term, is smaller than the next term and smaller than the term that converges, L in this case 3.3028, if my xn is between 0 and L. So how do we prove graphically? The first thing what I need to do is to draw the graph to represent my xn plus 1 and xn. So what I can do is I let my y-axis be the xn plus 1. That means I need to let my y-axis be this formula. And my x-axis, I'll let it be xn. Okay? So let's see what it means. Now, to plot the graph, I must change the mode back to function. I change it back to function and then I go y equals to. So I've earlier on before I start this lesson, I already input this equation inside. Okay? First thing I want to draw the y equals to, this is my xn plus 1 graph. You realize? You see this formula? Is this formula, square root 3x plus 1. And my line 2 is y equals to x, is this formula. So my line, the line that appear in my graph that I'm going to show you later is this. And the other line that appears, the other curve that appears in my graph is this one. Right. So let's see. Let's graph it. We'll see two graphs. Okay, which is which? How do I know which one is the graph? Which one is this graph and which one is the other? Y equals to x. This one, if you learn in secondary school, power of 1 is a straight line graph, isn't it? And the square root graph is a curved graph. Right. You don't believe, actually you just need to substitute various numbers inside and then you see that, for example, if I substitute x equals to 1, y should be give me 1. So x equals to 1, y give me 1. Then this is that means this line, the point on this line satisfy this equation. So every point on this line will satisfy this equation. And every point on this line, the x and y coordinate will satisfy this equation. Okay, so now look at the graph. How to look at the graph to determine this? So we first look at the condition given. They say if xn greater than 0 and smaller than L. What is my L? My L earlier on I found to be 3.3028. 3.3028 is the intersection point between L and this equation. In other words, it is this point. It is the intersection point between y equals to x and y equals to square root 3x plus 1. And this graph, the equation is what? Square root 3x plus 1. And this graph, the equation is y equals to x. So if I solve this equation, the L that I get is the x coordinate of the intersection point. If you don't understand what I'm talking about this point, you must go back to what we learned on simultaneous equation and graphical solution in secondary 2, correct? Is the simultaneous equation, when you solve it, the solution is exactly the xy coordinate of the line of intersection of the two graphs that represent the two equations. That when we do simultaneous equation on two equations, that two equations, each equation represent one graph, right? And if you do simultaneous equation, what we get out is one x value and one y value. And that x value and y value is the x coordinate and y coordinate of their respective graph. Okay, so now we have this. So this is 3.3028, we know. Okay, so we want to look at the part of the graph where the x-axis is between 0 and 3.3028. We want to look at this part of the graph that I'm writing out, right? Okay, so I'm marking out. You see, follow my cursor. You see, this part of the graph is what we want to see. Okay, because this is 3.3028 down here. We don't want to see anything else, right? You don't believe me, right? I changed the x maximum to 3.3028. Maybe 329, for example, and then we see. Now where do they intersect? They will intersect at the boundary. Exactly, correct. Close, because 3.3029 is here. This is 3.3028. So we want to see this part of the graph only. They tell us to see this part of the graph only. And then looking at this part of the graph, which graph is higher? This graph or this graph? Common sense, use your eyes. This graph is higher, correct? This graph is lower. And this is the xn graph. This is the xn plus 1 graph, isn't it? Isn't it? This is the xn plus 1 graph. This is the xn graph. Therefore, my xn plus 1 is above my xn. It means my xn plus 1 is greater than xn. Correct? That means this part of the equation is proven. Inequality, this part of the inequality is proven. I correct myself. This part of the inequality is proven because looking graphically, xn plus 1 graph is on top of the xn graph. Now, how to prove that xn plus 1 is smaller than L? Okay, where is the L graph? To plot L graph, I just need to plot one graph. I go down, I press 3.3028 and then I graph it. Now, do you see that this xn plus 1 between here and here, between here and here, 0 and L, my xn plus 1 graph is always smaller than the L, 3.3028. Therefore, my xn is smaller than L, right? Xn is therefore my xn plus 1 graph and both my xn and my xn plus 1 graph is smaller than L, isn't it? So I've proven this part of inequality. Xn plus 1 graph is smaller than L. So to write it out, I will say, okay, prove this one. Okay, so looking at the graph for between here, so I'm looking at this part and this part of graph. The graph of y equals to xn plus 1 equals to this thing equals to this inequality is above the graph of y equals to xn. This xn plus 1 graph is above the graph of xn. So that means this inequality is proven. And if you write it the other way, is also correct, right? And which is exactly this. And we also see that, right? We also, no, I don't want this. Okay, never mind. We also see that, oh, this is, so we also see that the graph y equals to L equals to 3.3028 is higher or above than or above the graph y equals to what? Therefore, what does it mean? Therefore, L is greater than what? Actually, I don't need this part. I just need this part. So I've proven this part of the equation, haven't I? So L greater than Xn plus 1. Here also means L greater than Xn plus 1. So if this is all seen from the graph, so nothing looks the same for these two. So now state briefly how the result in part 3, now we go to part 4, state briefly how the result in part 3 relate to the behavior described in part 2. So part 2 say the sequence increases and converges to 3.3028. Now, okay, if you look at what is our result in part 2, when x1 equals to 1, 1 isn't it between 0 and 3.3028? Yeah. So x1 is 1. It means that at that point, right, this is an increasing sequence. You see, the next term is greater than the current term. Is always greater than the current term, right? Let's say you might get a number between 0 and 3.3028. It will be an increasing sequence because the next term is greater than the current term, so it's increasing sequence. And since it's increasing, it will reach 3.3028. From 1 it increases, it will eventually reach 3.3028. Correct? Yeah. So which means the sequence of number is increasing from 1 and eventually it will converge to L. Okay, so let's do this. Okay, what if we are asked to prove something else? What if we are asked to prove that xn greater than xn plus 1 when xn greater than L? So I'll leave it as a question for you. Question. So you need this part of the graph to be, you need to look at this part of the graph. The maximum value I will now put as 10 perhaps, so that you can see the other part of the graph gets greater than 3.3028. Now, because they say, now if I give you a xn that's greater than L, then that means you must look at the graph that is here. Because here is 3.3028 3028. You must look at the graph that is greater than 3.3028, right? And you prove that. Tell me how you prove that xn is greater than xn plus 1 by looking at the graph, right? So that's for today. Any point in the video, you just need to go back and revise and ask me if there's any question. Okay, you can call me at, you can WhatsApp me at 8180 if you have any question on H2 Maths. Yep, so that's it for today.